Dr. Knag, and now we can start detailing.
Now we start detailing. Start detailing.
Number one.
Detail number one. Number one.
It was the standard, just horizontal sections through a standard facade.
Everybody remembers standard section.
Yeah.
So detail number one, and we.
That would be horizontal section, standard facade system.
1, 1, 2, and this is the number detail 1. And yeah, we wanted this as a system, so going to do it in half scale. So I need to make sure I have it the right size. I have to draw the detail as a system.
1 to 2 is actually kind of like a nice scale of it. You can see almost, you can see almost the thickness of the various layers. It saves a little bit of paper, and you can create quite a nice overview on an A4 paper.
And for a sketch design, I don't need to be super precise on everything. It's somehow allowing me to.
Later also it will be transferred into a cut detail.
Let's take this here, let's do the cover cap here, and
But we almost always start with hand sketches, so therefore so much easier to develop these details by hand on sketches.
So this is the detail, but there's also
so we need the
connection lines.
Connection lines. Often or usually the horizontal beams are a little bit shorter. It's a better detail precisely.
Why is this?
For instance, on the facade edge,
something horizontal.
they have a round over, so therefore, in order to have a nice detail here, that there's no sharp edges of the cutting edge of the profile, they are a little bit offset, and therefore you don't have to deal with the cutted aluminium being visible, the round over edges.
This is say the facade system suppliers talk. When I'm now an architect and I want to have this flush.
Yeah. There's also tolerances within the system. You want to make sure that it never protrudes out, for instance.
But it's an aluminium system. This is super precise.
Yeah, but
so yes, you can get it, but you raise the risk of, say, having tolerances. So yes, you can get it if you really want. You may get it, but it develops. It creates.
We would see it when we visit the company.
Right. Now, I'd like to do this as a three-dimensional sketch. So I somehow start with, let's say, the aluminium system and that's a sketch with not a perfect measurement. This is just a three-dimensional sketch.
Also, it's an isometric view.
Isometric view, and I have the insulated glass in here. I just draw it this way, then this.
Do you always do that in general?
I like to do that because it helps me to understand the system and where we are. It really helps you when I finish that one. It really helps you to understand, okay, this is the stick system, and I see a standard corner of a stick system. This is the outer view. Then there comes insulated glass at the bottom part. Then it continues like this. We see the inner line. And what you see is it really develops the full geometry of the object. You don't have to. This detail is, say, the main information which we need, but it helps you to identify. And then
it's, for the orientation, it's way easier. It's also, if you want to communicate on a set of drawings, it's always the easiest to jump into an isometric view, for instance, because then you can really see what is behind, which layer comes first. And especially, this is a standard cross joint, but later on, when we come to the various layers of vapor barriers, insulation, whatsoever, it becomes quite tricky. And then you want to make sure you have an overview.
So this is detail number one, the main section. This is the simple one.
I would always add a double line here, otherwise you can easily,
the double line.
Even in 1 to 2 scale, because then you can see aluminium extrusion profile whatsoever. Good, perfect.
Dr. Bilo.
Dr. Knag. Das war gut.